Engines are the heart of countless machines, from cars to airplanes. But have you ever wondered what really goes on inside? In this video, we'll take a deep dive into the fascinating mechanism of an engine. We'll break down each part, explain how they work together, and reveal the science that powers our modern world. Whether you're a curious beginner or a budding engineer, understanding engine mechanisms opens up a whole new appreciation for technology. Let's start by looking at what an engine actually is and why it's so important in our daily lives. At its core, an engine is a machine designed to convert energy into mechanical motion. Most commonly, engines transform chemical energy from fuel into movement, powering vehicles, tools, and even generators. There are many types of engines, but the internal combustion engine is the most widely used. This type of engine burns fuel inside a chamber to create power. Understanding this basic definition sets the stage for exploring the intricate parts and processes that make engines so effective and reliable. Engine block is the foundation of any engine. It houses the cylinders, which are the spaces where the pistons move up and down. Made from strong materials like cast iron or aluminum, the engine block must withstand high temperatures and pressures. It also contains passages for coolant and oil, helping regulate temperature and lubrication. Without a solid engine block, the entire mechanism would fail. Next, let's see how the cylinders and pistons fit into the structure. Inside the engine block, you'll find cylinders, hollow spaces where pistons move up and down. Pistons are cylindrical components that fit snugly inside these chambers. As the engine runs, pistons move in a precise rhythm driven by the combustion of fuel. This up and down motion is what ultimately gets converted into the spinning motion that turns your car's wheels. The number of cylinders can vary, affecting the engine's power and smoothness. Let's look at how pistons work with other parts to create motion. Crankshaft is a key player in the engine's mechanism. As pistons move up and down, they push on the crankshaft, causing it to rotate. This rotation is what ultimately powers the wheels or other machinery connected to the engine. The crankshaft must be precisely balanced and strong enough to handle the forces from multiple pistons firing in sequence. It's connected to the pistons via connecting rods, which we'll explore next. Connecting rods link the pistons to the crankshaft. As the piston moves up and down, the connecting rod transfers this motion to the crankshaft, turning it. These rods must be both lightweight and incredibly strong, as they endure intense forces during engine operation. If a connecting rod fails, it can cause catastrophic engine damage. Their design and material are crucial for engine reliability and performance. Combustion chamber is where the magic happens. It's the space at the top of each cylinder where fuel and air mix and ignite. When the spark plug fires, it ignites this mixture, causing a small explosion. This explosion pushes the piston down, creating the power stroke. The design of the combustion chamber affects efficiency, emissions, and power. Next, we'll see how air and fuel get into this chamber. Intake system is responsible for bringing air into the engine. Air enters through the air filter, passes through the intake manifold, and finally reaches the combustion chamber. The amount and quality of air are crucial for efficient combustion. Some engines use turbochargers or superchargers to force more air in, boosting power. The intake system works closely with the fuel system, which we'll discuss next. Fuel system delivers gasoline or diesel to the combustion chamber. It starts with the fuel tank, then moves through fuel lines, a fuel pump, and injectors or a carburetor. The fuel must be delivered at the right pressure and in the right amount for optimal combustion. Modern engines use electronic fuel injection for precise control. The fuel system and intake system must work in harmony for the engine to run smoothly. Spark plugs are small but vital components. They create the spark that ignites the air-fuel mixture in the combustion chamber. Each cylinder has its own spark plug, and the timing of the spark is controlled by the ignition system. If a spark plug fails, the engine can misfire or run poorly. Proper spark plug function is essential for power, efficiency, and smooth operation. After combustion, exhaust gases need to be removed from the engine. The exhaust system channels these gases out through exhaust valves, the manifold, and finally the tailpipe. Modern engines use catalytic converters to reduce harmful emissions. The design of the exhaust system affects engine performance and environmental impact. Let's see how all these systems work together in a typical engine cycle. Most internal combustion engines use a four-stroke cycle: intake, compression, power, and exhaust. First, the intake valve opens and the piston moves down, drawing in air and fuel. Next, the piston moves up, compressing the mixture. Then the spark plug ignites the mixture, causing the power stroke. Finally, the exhaust valve opens and the piston pushes out the gases. This cycle repeats rapidly, creating continuous power. Valve timing is crucial for engine efficiency. The opening and closing of intake and exhaust valves must be precisely synchronized with piston movement. This timing is controlled by the camshaft, which is driven by the crankshaft via a timing belt or chain. Advanced engines use variable valve timing to optimize performance at different speeds. Proper valve timing ensures maximum power and fuel efficiency. Camshaft is responsible for opening and closing the engine's valves at the right time. It has specially shaped lobes that push on the valves as it rotates. The camshaft's rotation is linked to the crankshaft, ensuring everything stays in sync. Some engines have multiple camshafts for better performance. The design of the camshaft affects how the engine breathes and performs. Timing belt or chain connects the crankshaft and camshaft, ensuring they rotate in perfect harmony. If the timing belt breaks or slips, the engine can suffer severe damage. Regular maintenance is essential to keep this component in good condition. Some engines use timing chains, which are more durable but still require attention. The timing system is a vital link in the engine's mechanism. Engines have many moving parts that need to stay lubricated to prevent wear and overheating. The lubrication system pumps oil throughout the engine, coating parts like the crankshaft, camshaft, and pistons. Oil also helps cool the engine and remove contaminants. Without proper lubrication, friction would quickly destroy the engine. Regular oil changes are crucial for engine health. Engines generate a lot of heat during operation. The cooling system circulates coolant through passages in the engine block and head, absorbing heat and carrying it to the radiator. There, the heat is released into the air. A thermostat regulates coolant flow to maintain optimal temperature. Overheating can cause serious engine damage, so the cooling system is essential for reliability. The oil pump is a small but vital component that keeps oil moving through the engine. It draws oil from the oil pan and pushes it through passages to lubricate moving parts. A failing oil pump can lead to rapid engine wear or even failure. That's why oil pressure is closely monitored in most vehicles. The oil pump's reliability is key to engine longevity. Radiator is where engine heat is released into the air. Coolant flows from the engine to the radiator where it's cooled by air passing through the fins. A cooling fan helps move air when the vehicle isn't moving fast enough. Together, the radiator and fan keep engine temperatures in check, preventing overheating even in tough conditions. Air filter cleans incoming air before it enters the engine. Dust and debris can cause engine wear and reduce efficiency. A clean air filter ensures only clean air reaches the combustion chamber, protecting internal parts and improving performance. Replacing the air filter regularly is a simple way to maintain engine health. Fuel injectors spray a fine mist of fuel into the combustion chamber, ensuring even mixing with air. Modern engines use electronic injectors for precise control, improving efficiency and reducing emissions. Clogged or malfunctioning injectors can cause poor performance and higher fuel consumption. Keeping injectors clean is vital for smooth engine operation. Throttle body controls how much air enters the engine. When you press the accelerator, the throttle opens, allowing more air in and increasing power. Modern engines often use electronic throttle control for smoother and more precise response. The throttle body's cleanliness and function are important for engine performance and fuel economy. Mass airflow sensor measures the amount of air entering the engine. This information is sent to the engine control unit, which adjusts fuel delivery for optimal combustion. A faulty sensor can cause rough running or poor fuel economy. Keeping this sensor clean and functional is important for modern engine management. Engine Control Unit, or ECU, is the brain of modern engines. It receives data from sensors and adjusts fuel, air, and ignition timing for optimal performance. The ECU constantly monitors conditions and makes split-second decisions to keep the engine running smoothly and efficiently. Software updates can even improve engine performance over time. Oxygen sensors monitor the amount of oxygen in the exhaust gases. This data helps the ECU adjust the air-fuel mixture for efficient combustion and reduced emissions. Faulty oxygen sensors can cause poor fuel economy and increased pollution. Regular checks and replacements keep the engine running cleanly and efficiently. Catalytic converter is a key part of the exhaust system. It uses chemical reactions to convert harmful gases like carbon monoxide and nitrogen oxides into less harmful substances. This helps engines meet strict emissions standards and protect the environment. A failing catalytic converter can trigger warning lights and reduce performance. The exhaust manifold collects exhaust gases from each cylinder and channels them into the exhaust pipe. It must withstand high temperatures and pressure. Cracks or leaks in the manifold can cause noise, reduced performance, and increased emissions. Proper design and maintenance are important for engine health. Engine mounts secure the engine to the vehicle's frame and absorb vibrations. They're made from rubber and metal, balancing strength and flexibility. Worn mounts can cause excessive vibration and noise, affecting comfort and even damaging other components. Regular inspection ensures a smooth and quiet ride. The flywheel is a heavy disc attached to the crankshaft. It stores rotational energy and helps smooth out the engine's power delivery. The flywheel also plays a role in starting the engine and in manual transmissions, helps engage the clutch. Its mass and balance are important for smooth operation. The starter motor is an electric motor that turns the engine over when you start the vehicle. It engages with the flywheel to get the engine moving until it can run on its own. A weak or faulty starter can prevent the engine from starting. Reliable starting is essential for daily use. The alternator generates electricity to power the vehicle's electrical systems and recharge the battery while the engine runs. It's driven by a belt connected to the crankshaft. Without a working alternator, the battery would quickly drain and the engine would stop running. The alternator is vital for modern vehicles. Serpentine belt drives multiple engine accessories including the alternator, power steering pump, and air conditioning compressor. It's a single, continuous belt that winds around various pulleys. If the belt breaks, many systems will stop working. Regular inspection and replacement are important for reliability. A power steering pump makes it easier to turn the steering wheel by providing hydraulic pressure. It's driven by the serpentine belt and circulates fluid through the steering system. A failing pump can make steering difficult and noisy. Proper fluid levels and maintenance keep steering smooth and responsive. The air conditioning compressor is another accessory driven by the serpentine belt. It compresses refrigerant and circulates it through the AC system, cooling the cabin. A faulty compressor can lead to poor cooling or strange noises. Keeping the AC system in good shape ensures comfort in all weather. Modern engines use a variety of sensors to monitor temperature, pressure, position, and more. These sensors feed data to the ECU, which adjusts engine operation for optimal performance and efficiency. Faulty sensors can cause warning lights and poor running. Regular diagnostics help keep all sensors working properly. Turbocharger uses exhaust gases to spin a turbine, which forces more air into the engine. This increases power without increasing engine size. Turbochargers are common in modern engines for better performance and fuel efficiency. Proper maintenance is important to prevent damage from high temperatures and speeds. Supercharger also increases engine power by forcing more air in, but it's driven by the engine itself rather than exhaust gases. Superchargers provide instant power and are often used in high-performance vehicles. Like turbochargers, they require strong components and careful maintenance. Variable valve timing systems adjust the timing of valve opening and closing for better performance and efficiency at different engine speeds. This technology allows engines to be both powerful and fuel efficient. It's controlled by the ECU and relies on precise sensors and actuators. Direct injection systems spray fuel directly into the combustion chamber rather than the intake manifold. This allows for more precise fuel control, higher efficiency, and more power. Direct injection is common in modern gasoline and diesel engines. Keeping injectors clean is important for proper operation. Engine cooling fans help move air through the radiator, especially when the vehicle is stationary or moving slowly. Electric fans are controlled by the ECU and turn on only when needed. This helps maintain the right engine temperature and improves efficiency. The oil filter removes contaminants from engine oil, keeping it clean as it circulates. Dirty oil can cause wear and reduce engine life. Replacing the oil filter regularly is a simple but important maintenance task for engine health. Gaskets seal the joints between engine parts, preventing leaks of oil, coolant, and gases. Common gaskets include the head gasket, intake manifold gasket, and oil pan gasket. A blown gasket can cause major engine problems. Regular inspection and replacement are important for reliability. The positive crankcase ventilation (PCV) valve helps remove harmful gases from the engine's crankcase and recirculates them into the intake for burning. This reduces emissions and prevents pressure buildup. A clogged PCV valve can cause oil leaks and poor performance. Let's recap the many sensors used in engines: temperature sensors, pressure sensors, position sensors, and more. Each plays a role in monitoring engine conditions and sending data to the ECU. This network of sensors allows for precise control and efficient operation, making modern engines more reliable and powerful than ever. You've explored the intricate mechanism of an engine, from the engine block to advanced sensors and control systems. Understanding these components helps us appreciate the engineering behind every vehicle. As technology advances, engines are becoming more efficient, powerful, and environmentally friendly. Hybrid and electric powertrains are the next step, but the core principles of engine mechanisms remain essential knowledge for anyone interested in how things work.